String theory offers a new idea. It is about the universe's core. What are things made of fundamentally? Not tiny points, this theory suggests. Instead, matter consists of small, vibrating strings. These strings are like tiny loops, or perhaps minuscule segments of pure energy. This is the basic revolutionary picture. Why do we even need this theory? Physics has two great pillars today. General relativity describes gravity, stars, galaxies. Quantum mechanics describes atoms, particles. But these two theories currently clash. They do not speak the same language. String theory attempts to unite them. It seeks one harmonious description. These fundamental strings are incredibly small. They are far smaller than an atom. Smaller even than an atom's nucleus. Smaller than anything we have ever seen. Their scale is the Planck length, about a millionth of a billionth of a billionth of a billionth of a centimeter. This unimaginable smallness presents challenges. Observing them directly is beyond current technology. The ultimate promise of string theory is grand. It aims to be a theory of everything. This means one single framework, one set of fundamental laws and principles, explaining all the forces of nature, explaining all the elementary particles. It seeks to reveal the universe's deepest secrets, a single equation perhaps for everything. Older physics viewed particles as simple points. They were considered tiny, dimensionless dots. This model worked remarkably well for centuries. It explained many physical observations accurately, from falling apples to planetary orbits. But this classical view was incomplete. It could not explain everything we found, especially at the very smallest scales. Problems began to arise in the quantum realm. When gravity met quantum mechanics, trouble started. Calculations involving point particles led to infinities. This signaled a deep, fundamental problem. The idea of particles as mere points broke down. Our understanding needed a radical revision. A new way of thinking was required. The old picture was not enough. String theory offers an elegant solution here. Strings are not zero-dimensional points crucially. They possess a tiny but definite length. This slight extension smooths out the problems. It naturally tames the troublesome infinities. This happens without artificial fixes. This is a key and attractive feature. It resolves a long-standing puzzle. This shift in thinking is truly revolutionary. It changes our most basic understanding. The very fabric of reality is different. It is not just dots moving through space. Instead, we see a universe of vibrating energy, tiny one-dimensional strands dancing in space-time. This is a profound departure from past ideas. A new cosmic language is being learned. Imagine playing a simple violin string. It can vibrate in many different ways. Each specific way produces a distinct note. You might hear a low, resonant note, or you might hear a high, sharp note. Many different sounds arise from one string. This analogy is central to string theory. It helps us visualize its core idea. String theory proposes something very similar. Elementary particles are like these musical notes. An electron is one particular vibration pattern. A photon, the particle of light, is another. A quark, found inside protons, is yet another. All these diverse particles emerge from one entity, the fundamental vibrating string itself. Different notes create different particles. The universe, then, is a cosmic symphony. All the myriad particles we observe around us, all the fundamental forces that govern interactions, they are simply different melodies being played out by these unimaginably tiny strings. Our universe is filled with this subtle music, a rich tapestry of vibrations and resonances. This is a beautiful and compelling image. I have often used this musical metaphor. It helps to explain this complex concept. The laws of physics become the rules of harmony. The strings must obey these cosmic rules. Their vibrations create the universe's rich diversity. From the smallest atom to the largest galaxy, it paints an elegant picture of reality, a universe singing its own song. String theory is still actively developing today. It remains a work in progress for physicists. We do not yet have direct experimental proof. No experiment has definitively seen a string. This absence of evidence is a major hurdle. It keeps the theory in the theoretical realm. Many brilliant minds are working on this. The search for proof is paramount. There are certainly very significant challenges. The mathematics involved is incredibly complex. It pushes the boundaries of our current abilities. String theory also predicts extra dimensions of space, perhaps 10 or 11 dimensions in total. We only perceive 3 spatial dimensions, so where are these other dimensions hidden? This is a key question to answer. Scientists are actively looking for any evidence. Perhaps clues lie hidden in cosmology. The very early universe might hold vital signs. Particle accelerators like the Large Hadron Collider search. They could find indirect signs or new particles. These could point towards string theory's validity. The global scientific quest continues with passion. Every new discovery is scrutinized carefully. So, what does the future hold for us? Will string theory eventually be confirmed as correct? Will it truly become the theory of everything, or will it perhaps lead to even deeper new questions? The universe's grand symphony is far from over. Its most profound melodies may still await discovery. What new harmonies will the future unveil? The quest for understanding continues as always.